Alright, today we'll be talking about logarithms. And logarithms are, basically logs are inverse operations of exponents. Okay, now you guys have learned this already in Algebra 2. So logarithm rules, y equals a to the x can be switched to x equals log base a of y. Okay, this is exponential form right here on the left, and this is logarithmic form on the right. Alright, now you've worked with logarithms before in Algebra 2. Just some reminder of rules. When you see a log of two numbers being multiplied, you would add the logs together. If you see logs of two numbers being divided, you would subtract the two logs. If you see log of a number being raised to a power, you can bring that number down to the front and multiply it by the log. Now if log of m equals log of n, this is a really good one if you're trying to solve a logarithmic equation, then m equals n. And that's a really great, wonderful process to actually go through. Alright, log base a of a is 1, okay, and log of 1 is actually going to be 0. Okay, and this could have any base whatsoever. Alright, now also, log base a of a to the x is also x. So if I'm raising that number to the x power, it's going to be x. Okay, a to the log base a of x is also going to be x. So this is, now the log is in the exponent, so that's something interesting. Alright, now if you wanted to do change of base, this is the change of base rule. Log base a of x equals log of x divided by log of a. Okay, and log base a of x equals, if I wanted to do a switch of base of change, this is actually a really cool property. Log of a base a of x is equal to 1 of log base x of a. Really interesting. Now if we try to do logarithms at anything below 0, it's definitely going to be undefined, because what logs are actually telling you is their answers are going to be the power. So usually, normally we would go, oh, 5 to the third is equal, and then we have to fill in the answer, which is 125. But then logarithms ask the question, 5 to what power is going to be, let's say, 625. And so logarithms actually answer that question. Okay, since we're looking at the answers to actually be positive, because when we raise something to the power, it's going to be positive, we can't have negatives right here. And if you notice up here in the log base rule, the usual answer is y. Well, now it's right here. And if we can never get a negative number here, because if you take a look at the graph of a exponential function, it goes like this. Since logarithmics are inverses, you can never get a negative x. Okay, so this can never happen over here. All right. Now, as you guys are working, please, please, please take your time to work with logarithms and make sure you write down all these rules and use them at all times. Okay, and just work with them the best you can. Alright, so here's some problems set up like this, okay? Alright, so now when you read this, you're thinking of, okay, 2 to what power is 32 on this one, okay? And that would actually be the 5th power, so that's the answer there. Now 216 to what power is 1/6? That would actually be the cube root, so that would be 1/3, okay? And 8 to the, 8 to what power is 1/64? Well, you have to think it's almost like the negative exponent, so it's going to be -2. Okay, now your answers for this can be negatives because they are the exponents. These are literally the exponents. These aren't the answers to the normal questions we're used to. The answers are all right here. Okay, now we do need to keep this, and as you can see, this is really close to 0. So it's close, but it's no cigar, so it won't be too harmful. Okay, now solving equations is a lot of fun when you're working with it. Okay, because all you need to do is basically you need to get one log equal to another log. Now I am using this thing called the common log. I'm not writing the bases there, but you can have the bases there if you want, like a 2 or a 7 or something. It just takes too long to write. So I'm just using logs right now, common logs. Now on this one, even though it's addition here, we are going to multiply these two so we can shorten this. So this becomes log of 2x plus 11 equals log of 10x. Okay, and now when you have these two logs being equal to each other, you can use the rule of when two logs are equal to each other, then the numbers they are of are going to be equal. So this is going to be equal to 10x, and all you need to do is solve it. And 11 is going to be equal to 8x, and then we divide both sides, so 11 divided by 8 equals x. Okay, now if we plug back in x, we should get some positive answers. So you do need to check your answers by plugging it back in. So you would plug back in here and plug back in here, and as long as you get positives, you should be okay. All right. Now graphing is going to be really easy, and I love Desmos for this. Okay. All right, so what you do is you go into Desmos and you're going to use the keyboard function. You press ABC. And what's going to happen is that you're going to notice that there's a subscript down here. The subscript is what you're going to use when you're typing. So if I wanted to graph y equals log base 2 and I wanted a base on here, okay, if I just type in log of 2, this is just going to be, you know, pretty easy, simple stuff. It's not going to be subscript. So I have to go down to the bottom and I have to press base, and that will bring my cursor into the base, log base 2 of x. Okay? And voila, I actually have it, and I can graph all kinds of different bases. And as you can see, when you click back down there, you can change it to log base 10, you can change it to log base 5, you know, all kinds of crazy stuff that you want to do with it. Okay? And that's the amazing thing about Desmos that can actually work. Once again, you press the ABC on your button and then use this button right here to actually get to the subscript button. Okay? All right. That is it for working with logarithms. And just remember, take your time and just work with it very carefully. Okay? Bye.